to the cloud. All right, so let's start. So this Facebook timeline, like I mentioned earlier, basically shows the main technology milestones since 1905, and the technologies that might be relevant or promoted to development of civil engineering and construction. So the first one I found was the first UAV use. That was in 1916. So basically, that was the first time that people used radio to control this unmanned airplane. And later on, this unmanned airplane was used in World War I and also World War II. Okay, so nobody will take this, right? And this 1925, the term robot was first used in a play called RUR. So that's, we created the term robot. All right, so that's 1925. I'm not sure about this one, but this is actually the Empire State Building that was built in 1931. Okay, so that's 90 years ago. By the way, I actually went to that building 3 years ago. Okay, so this is interesting. The three laws of robotics. Yeah. Somebody said something. Okay, so the three laws of robotics. So this is Asimov's law, set the rules by the science fiction author Asimov, Isaac. And so this is in 1941. I cannot recall the details of the three laws, but you guys know them, right? So I guess the number one law is robots can never hurt human beings, right? The number two is must obey the order of human beings. Unless is violating the first law. And then the third one is robots will need to protect themselves. Unless it's violating the first and the second law, things like that. So basically shows that not hurting people is actually the number one, the highest priority for robots. But actually there's some interesting story that is still a research topic. In some auto manufacturer, actually the robots killed some workers in 2014 and 2017. I don't know if you heard about that. The robotic arms, they didn't know the presence of workers, and they killed 2 people in the US and 1 person from the German. Okay, so we still have a long way to go in terms of the robotic intelligence. RFID, we will talk more details of this interesting story, but RFID is I think this is radio frequency, I can't forget that, the full name. So this is anyways using the radio to transfer information, and we have the active RFID and the passive RFID. The passive RFID means it doesn't require any battery. So this is the first RFID called the Thing. Actually was created by Russian engineers, and they put this as a spy tool in the embassy building, the US embassy building in Moscow. And this was a passive RFID. It basically documents the conversation, and because when we speak something, the vibration itself is energy. So this device actually transfer the vibration into the power to support itself while document everything. And Russian government actually put a car outside, a block away from the embassy building. And so that vibration energy from our conversation is strong enough to support this one to actually send radio to that receiver and document everything. So that's also an interesting story. I'm not quite sure if this one includes the video, but there's a video on YouTube showing that how US presented this tool at one of the UN meeting. Okay. All right, so 1964, the first computer called, I don't know how to pronounce that, Eniac. And this is, let me see some details. So the Eniac could perform 5,000 calculations per second. And to give you a reference, i7 CPU can perform more than almost 300 billion calculations per second. And it took a room to store this Eniac. By the way, can you guys hear the sound from my PC? No? Can you hear the sound? Okay, let me see. There's an advanced share function, share screen, advanced share computer sound. That should be working.
Proposed building a giant electronic computer that could figure charts in minutes.
You can hear the sound, right?
The Army, desperate for a device to help them win the war, reluctantly committed to the proposed cost of $500,000. Mockley and a brilliant graduate student in electrical engineering, Presper Eckert, set to work constructing Eniac, the electronic numerical integrator and computer. Many times larger than Colossus, nothing close to Eniac had ever been conceived. Nearly 100 feet long and weighing 30 tons, it contained almost 70,000 resistors, 10,000 capacitors, 6,000 switches, and 18,000 delicate vacuum tubes. Vacuum tubes burn out just like light bulbs. In a machine that contained 18,000 vacuum tubes, at least one had to be replaced every few minutes. After 2 years of intense work, the team completed Eniac, 3 months after the Japanese surrender. Although it wasn't finished in time to help win the war, Eniac was a marvelous machine. It could perform up to 5,000 additions, 357 multiplications, and 38 divisions every second.
The interesting thing about the Eniac.
Okay, let me stop here. It's just to give you a sense. Of course, we are not going to research this older computer. Okay, so this is 1956, and because the development of a computing device, construction companies started to use computer to perform scheduling. For example, like finding out the free flows, total flows, finding out the critical paths. At that time, we call this critical path management or critical path analysis. Did you guys learn that, critical path analysis?
Yeah.
Okay, so that basically means out of the hundreds of activities or maybe thousands of activities, you discover, that chain of activities that you cannot delay, right? So the chain of activities, if you delay just one of them, the entire project will be delayed. So that chain we call this critical path, right? To find out the critical path is very important because we know we need to pay special attention to that list of activities without delaying the entire project. Manually doing that could be very time consuming. So they started to use this computer called the Eniac. One computer, so that's a collaboration, DuPont and with industry partners. So they started to actually use this one to perform computerized scheduling. All right. So that's 1956, and what's this? 1958. Learns by doing. Oh, so I think this is more about machine learning. So they basically, we had that concept of machine should learn from human beings, like how we perform things, how we do things, how we think. So in 1958, they created the first machine learning device that will be able to walk, talk, see, write, reproduce itself, to be conscious of its existence. Of course, that was sci-fi at that time. I do think that a machine should be able to learn, to repeat something that we teach it, but I don't think at that time the machine actually has the intelligence we have today. But anyway, 1958, we started to think about how to train machine models to behave like as we want. This is what? PERT. Okay, so program evaluation and review technique. Can any of you tell me what PERT is? Nobody? So PERT is actually a military way to perform schedule analysis, and this method considers uncertainty, and that's critical, that's important. So let's say if I have a project with 3 activities, and each activity, if I know for sure that each activity will take 5 days, then what's the total duration for that small project? 3 by 5, that's 15 days, right? But what if I tell you each activity follows a distribution? it's a minimum, maximum, and the most likely. So the most likely is 5 days, okay? I have 3 activities. Most likely, each of them will take 5 days, but minimum could be 3 days, maximum could be 8 days. Then let me ask you guys a question. 3, 5, 8, yes. What is the most likely total duration? Can any of you tell me that?
8 days.
Most likely. So let me share.
Is it 5 days?
That's also not correct, even it's close. That's why we need the uncertainty analysis.
It's A plus 4 M plus B by 6, I guess.
Exactly. Who said that?
It was me. Hari.
Okay, so why did you know that?
I mean, I took the project, the planning class. So
Okay, nice. All right, so let me join the meeting. Hold on just a second. Oh, I'm trying to use my iPad to log into this meeting so I can basically sketch the thing, but it just tell me to wait. I don't know why. So let me try it again. This one. Okay, so what it means, I guess. So if you have a number of activities and each activity, you are not sure about the duration. And even though you know the most likely duration for each activity, unfortunately, the total most likely duration of the entire project is not a simple addition of all the most likely. So this is the status, this is probability. And so military develops a very simple formula to find a similar, to approach the answer to that. So this is called the PERT technology. Otherwise, you have to run some computer simulation, Monte Carlo simulation to find out the distribution of the entire project. You guys understand the point here? Okay, so that's actually unable to connect. What that mean? I miss my office so much, but one thing I don't miss is the Wi-Fi here in Vale Hall. Just having trouble, always have trouble connecting to the Wi-Fi here. That's ridiculous. Okay, anyway, let me keep going. So this is the modern era of robotics, began around 1959. Yeah, I'm not sure about this, but I think these two engineers proposed the concepts of the modern robotics. So that's almost 1960s. Virtual reality. So this is a 1960 showing, this is a Python showing that at that time, 60 years ago, people started to envision how the future VR should look like. Let me see what's this. Computerized, this is ERP, enterprise resource planning. So this is, you can imagine this is kind of like the cloud server today, and also like the HR system, financial system that is so common for us to use today. At that time, that was a milestone. 1960, we started to think about how we can use computer to help all the phases of the business management. So LiDAR actually is very common for civil engineering, for building scanning, for bridge scanning. So LiDAR was first developed and created in the 1960s. So this is 1963. We did that because we want to check the thickness of the cloud. That parameter is important for the weather forecasting. So we actually pointed to the sky first, but now we pointed to the ground or to the building. So that's 1963. I'm not very sure about this. Augmented reality, let me skip this one. Robots. Oh, this is the first mobile robot. Oh, that's amazing. That's 60 years ago. We already have this Turbot, which we call Turbot today. The view, robots with view and can move freely. That's 1966. Okay, RFID tag. So RFID tag is actually also very common for construction operations. Like if we put this RFID tag on the major machine, the equipment, we can track their location. We can basically document the information. And also, what is the tag we use for the toll road? Sunshine Pass, is that a Sun Pass, right? Okay, so Sun Pass is actually also RFID technology. It stores all your vehicle information. Okay, so inventor RFID, we'll skip that. Beam, 1975. Okay, so this is the BDS, we talk about that, right? So the building description system, Chuck Eastman, at that time was an assistant professor at the Georgia Tech, and he proposed the concept of building description system that shall be used in the future. And he said, we should give up on all the piecemeal information, different ways to store and exchange information. We should store everything in a single integrated database, which is Beam today, all right? Structure from motion, that is 1976. I mentioned the photogrammetry. You guys still recall that, right? Photogrammetry is a technology that you take a whole bunch of pictures and you can reproduce a 3D model. The mathematical base of that is called structure from motion. So it's basically based on, by comparing the difference of two pictures, I can also reproduce how you move the camera. Knowing that is very important because in order to reproduce the 3D model, I have to know how far it was from my camera to the object, right? So that's the depth information. And a critical step that was missing for a long time was, can I just use pictures to also reproduce the pose and position X, Y, Z from my camera? It was created by a brilliant student at MIT. It was a homework. That's also, we always heard that kind of story, but this story also was a true story. It was a homework. The professor proposed, say, you guys just brainstorm that. And I don't expect an answer because nobody knows how to do it. Then this smart guy spent a week or two and basically proposed a solution and called it structure from motion. And that guy now is a professor at Israel Technology Institute, all right? So he proposed this mathematical basis. We will cover that later. First AutoCAD system, okay? That's 1977. Let me skip this one. 3D printer, 1999. So we started to have this 3D printer, okay? Still, none of you guys made this? Cobalt, none of the team? All right. So in the 1990s, the Cobalt concept started developing. Unlike robot, Cobalt is the abbreviation for collaborative robot. It's a human-robot collaboration. It highlights the need for robots to assist human activities, but also during that process, how robots can learn from humans. So it's a co-evolving strategy to develop a better relationship, and that's called Cobalt. Cobalt is actually more popular today than robot, all right? This is the first smartphone in 1992, okay? By IBM. Singularity. Okay, so
Oh, it's group 2, the Singularity.
Singularity. Okay, all right. So now it's group 2, guys. Okay, now please also use the link I shared with you guys to put in your evaluation. Okay, go ahead.
Okay. In 1993, the author and computer scientist Vernal Vinge published an article about the coming technological singularity, and he predicted that within the next 30 years, humankind would create a superhuman intelligence, but it's already 2020, and I don't think it may come true, but in the next 30 years, around 2050, I think it may come to have some story. So about the details thing, let's welcome Jun Yiduan to introduce about it.
Professor, can I share my screen?
Okay, sure. Just a second. All right, you can go.
Okay. Can you see my screen? Can you see my screen?
No. Oh yeah. No. How about you guys? I cannot see any. Just there's a green button called share screen. Just go there and share your screen.
Sorry, I can't see that. Okay. Okay.
All right. Yes.
Okay. Can you? Oh.
Yeah, we can see it.
Okay. Thank you, Wendy. We are group 2, and I'm Jun Duan. I'm gonna introduce what is singularity. And you guys can see this picture. And we humankind evolved from ape. And after a humankind, you can see a lot of zeros in the eyes and or data. So after singularity, whether we human will be replaced by AI, and that's an interesting question. Okay, let's go through and to learn what is singularity. The technological singularity, also simply the singularity, is. Oh, sorry. It's a hypothetical point in time at which technological growth becomes uncontrollable and irreversible, resulting in unforeseeable changes to human civilization. And in 1993, author Bernal published an article which popularized the idea called the coming technological singularity. He predicted that within the next 30 years, humankind would have the ability to create superhuman intelligence. Shortly after, the human era will be ended. And after that, let's watch a video about what is singularity. And in this video, you can also to have some information about what if it really happens.
Hey, Junyi, I don't think we can hear you.
Okay.
So when you share your screen, there's a advanced share function, and so when you share your screen, go to the central button. There's called advanced setting, and go there. There's a little chat box called share computer sound, and then everybody can hear your computer sound.
Okay.
Years ago, 4 million years later, and humanity discovered fire. In between, not much was happening. Hunt, eat, sleep, reproduce. The first settlements, the wheel, the use of iron, the first written languages, all happened in the last 10,000 years. And only in the previous century or so has electricity been adopted worldwide. It is undisputed that the pace of scientific advancement is accelerating. If you were to teleport someone from the year 500 to 1 millennium later, they wouldn't notice much of a difference. One from 200 years shall, in the near future, reach a point called the technological singularity, a term coined by the futurist, Weil. This represents the moment in which the intellectual capacity of artificial intelligence surpasses that of the human brain, and that will turn everything upside down. It is important to mention that this might very well happen during your lifetime. Several polls have been conducted within the scientific community, suggesting that the singularity might take place somewhere between 2040 and 2050. So, what will happen with humanity during and after this point of no return? Let's find out. Once the first artificial intelligence reaches the level of human intelligence, it will only be a matter of months or even days before its intellectual capacity surpasses that of the entire human race, all because of exponential improvements. As argued by Stephen Hawking, this superintelligent AI poses the greatest threat to human existence. And trying to contain it will almost certainly not work. Imagine if a 2-year-old tries to stop you from going outside of your house. That's how an AI would see humans. But should humans even try to stop the AI? If humanity doesn't pose a threat, the artificial intelligence won't bother harming it. Depending on its moral compass, it might even decide to help humans. And this is where the good part starts. Imagine an incorruptible and correct ruler, who will always do what is right. No more pointless wars, no more poverty, justice will prevail. The exponential increase of intelligence will also allow for advancements in the field of nanotechnology. Swarms of nanobots could be inserted into the human body that would aid with the prevention of most of the diseases, cancer and circulatory issues being few of the many. Theoretically, cells could also be manipulated by nanobots so that they never die, resulting in immortality. Another important area which will be improved upon is gene editing. Through careful manipulation, first all the genetic disorders would be wiped out. The next thing to come would be genetic improvements, such as higher intelligence, better health, longer fingers. But that would of course create additional problems, such as the world being divided between simple and genetically improved humans. Expect class wars. But the gene editing period could come to an end as quickly as it appeared. That is because of the technology of mind uploading. If computers become sufficiently capable, they could scan the human brain and replicate it into digital form. And from this point on, the possibilities become endless. No more need for physical bodies. All the human consciousness will be living in some sort of internet. No more hunger, no more physical suffering, no more biological death. But what about mental health? Several mental illnesses are caused by chemical imbalances in the brain. The human mind is connected to the body and all its sensory organs. If we convert it to a digital form, there might be a chance that everyone will become insane. The concept of time itself might be lost, as a digital mind could perceive reality millions of times faster than the biological brain. And that could lead to some horrible results, like being imprisoned for millions of years, even an eternity, without the possibility of dying. But on the bright side, the digital beings can have an almost free reign over their perception of reality. Think of a game, but completely immersive, where only your imagination is the limit. Your most desirable fantasy will become your subjective reality. This really starts to sound like an ad for a VR headset from 2050. But at the same time, everything that we take as granted now will be gone. No more organized society, no cities, no food, no nothing. Most likely the future civilization will build a Dyson sphere around the sun to collect the energy used to power the planet-sized computer that hosts all the consciousnesses. This could also explain the apparent lack of aliens in the universe. What if all civilizations that live long enough get to the stage of mind uploading, and after anchoring themselves close to their home star, stop expanding outwards? Instead, they would live for the rest of time inside their greater internet. Since this offers almost limitless possibilities, what would motivate someone to explore the outer universe? The answer is most likely nothing. And that might also be the reason for why humans haven't yet found any sign of intelligent life, and might never will. And in this post-singularity world, where no suffering and only complete control over one's imagination will exist, what will be the meaning of life? Now one has many answers: family, accomplishment, God, knowledge. What about when everything you can wish for can become true? Will that be enough to satisfy your desire for a meaning of life? Or will it make you crave one even more? Perhaps the answer will be hedonism, as people will numb themselves with never-ending pleasure. Or it might be the total opposite, nihilism. If people will realize that they live without a purpose and are no longer chained by their biological rules, they could decide that such an existence is pointless, and end it once and for all. Who knows, maybe such is the fate of all civilizations, to reach the level of gods only to voluntarily cease existence. Or they shall somehow transcend space and time, and reach true divine levels. The possibilities are countless, and you are lucky to have been born now and possibly experience the singularity with your own eyes. But until then, we need to continue developing sky.
Okay. What if it really happens is an interesting question for us. Like in the first class we took, the professor asked us, what if it really happens? And different people have different opinions about that. Like the people will replaced by AI or will continue to alive. So in my opinion, I think we could never replaced by AI, because on our human, we have emotions. We will consider more things rather than the thing itself. So, I finished my part of singularity.
All right, thank you, Junyi. And just to remind everybody, I think it's 4 a.m., 4:30 a.m. in China right now. All right, so any additional comments from you guys? This is team 2. Anybody? No? Okay, so I think this is a pretty negative, opinion in artificial intelligence, and this is a popular concept, singularity. I think I mentioned earlier, the Time magazine actually predicted a singularity in 2035. And people have been talking about that, but there's also ongoing argument. Some people say AI would never take over or take control of the humanity. But somebody say, somebody do have this kind of negative impression. We will see, 2035 is not a long time, just another 15 years. All right, so is that all from your team?
I know we have two different parts.
Oh, okay, so they keep going then. Yeah, keep going.
Okay. Okay. Next topic I'm gonna talk is the theory. First, I want to introduce the origin of theory. Sorry. First, I want to introduce the origin of theory. Theory is a spin-off from a project originally developed by the SRI International Artificial Intelligence Standard. So I want to talk here is theory is not technically a product produced by Apple itself, and the very important part is developed by another company. Okay, let's a very short video about the origin of theory.
I've been loving you too long.
App Store in 2010. The signature voice for Siri was provided by voice actress Susan Bennett, and there were also British and Australian voices available for Siri provided by John Briggs and Karen Jacobson. After the Siri app had been live for 2 months, Apple acquired the company and integrated the voice assistant into the iPhone 4S. Apple then removed the Siri app and limited the feature to the 4S even though the app had supported the iPhone 4. It was clear Apple used Siri as the new shiny feature to entice customers to upgrade their devices, but we know the feature could have been made available for at least the iPhone 4 since Trofton Smith, working with an anonymous partner, managed to
stop here. And after that, I'm gonna introduce an application Siri, Apple HomeKit. And it's an app that we can use Siri to join the IoT system. And that's convenient on life. And HomeKit is a software framework by Apple that lets users configure, communicate with, and control smart home appliances using Apple devices. And now HomeKit currently supports 22 device categories like AC, fans, doors, and lights, and so on. Okay, let's watch a video about how we can use the HomeKit and by using Siri to control the smart devices in our house.
Hey Siri, turn on ensuite light. Alexa, turn on Xbox.
And this Alexa is also a voice control product that's produced by the Amazon. So you can just take it as a Siri. They are the same product.
Xbox One.
Okay.
Alexa, turn on telly.
Okay.
Alexa, turn on Full HD.
Okay.
Alexa, turn off telly.
Okay.
Hey Siri, set bedroom main light to 30%. Hey Siri, turn on Xbox One. Alexa, turn on decking lights.
Okay.
Alexa, turn on outside light.
Okay.
Alexa, set big lamp to 30%.
Okay.
Alexa, set big lamp to 100%.
Okay.
Alexa, ask house if any doors are open.
The patio door is closed. The front door is closed.
Alexa, ask house if any doors are open.
The patio door is closed. The front door is open.
Alexa, tell house it's morning.
Good morning.
Okay. Okay, you can see the video that and it can detect whether the door is open or not, and it's by a door sensor. And you can see in IoT, and it also depends on a lot of sensors like the CPS system. Okay, you can watch this video, or you can watch this picture, and that's a smart bedroom. There are several smart devices from different companies, but you can control them all from IoT. And for example, if you just get up, you can say, "Hey Siri, open the light." Sorry, when my Siri wakes up, you can say, "Hey Siri, and open the lights and open shadows." And you can still stay in bed rather than get up to do those things. And it's very convenient. And there's also a very popular app in iPhone that's shortcuts. By using this app, you can program your own instructions. Like I said, "Good morning" as my is my tip. So every time when I say, hey Siri, good morning, it will automatically open the lights and open the shadows for me. It's very convenient and let me enjoy a smart and ideal life. Thank you. And that's all of my part.
All right, thank you, Junyi. And any more comments from you guys or from this team too?
Wait a minute. About this part, we still have a short video about it. Let me share my screen. So it seems that the voice control really facilitates our daily life. You can control your house devices by using the voice control, but what is it really help us to? I'm sorry. So does it really simplify our life? Can we just replace?
Writing's not that easy, but
are we supposed to replace all the devices into voice control? So here's
Grammarly can help. This sentence is grammatical.
Play jazz.
Playing jazz.
Smoothie.
Making smoothie.
Calendar.
No meetings today. Remember, dentist at 9:30.
Fire off.
Fire off.
Open door.
Door open.
And we're gonna do one more.
Oh yeah. Open door.
Wrong voice command.
Open door.
Wrong voice command.
Open door.
Repeat that.
Open door.
I didn't understand that.
Hey, open door.
Play on the floor.
Get over the floor. Open the door.
Wrong voice command. Error.
Hey there, with a rock. Open door. Open door. Higher.
Higher volume.
Higher.
So it's quite funny. It's about a Norwegian supermarket chain advertisement, but it also reveals the potential problem that caused by the voice control. So in my opinion, I think that humans should not totally depend on the artificial intelligence to make them live more lazy or something. So is there anyone want to comment or discuss something?
Anybody? Yeah, that's funny. Okay, so is that all your team have?
No, the third part of us is about Alphago. So Alphago was a computer program that developed by DeepMind Technologies in 2014, and then no, it's much earlier than that. And then it was acquired by Google in 2014. And Alphago was designed to play a board game called Go. And here's its record. In October 2015, the original version of Alphago beat professional Go player without a handicap. And it was the first time a computer program beat a professional player. And in March 2016, it's widely known that Alphago defeated the Go world champion Lee Sedol in 4 games to 1. And about 60 million people watched this game. And it's such a landmark because Alphago just beat the highest rank of Go player. And in 2017, the master version of Alphago beat Kejie and he was the #1 ranked player in the world that time. And after that, the Alphago retired with honor. And another computer program called Alphago Zero has it is completely a self-taught program. It can learn. It was totally learned by itself with a machine, and it achieved a 100 versus 0 victory against the early competition version of Alphago just in 3 days. And now it learned about the chess and also the shogi, a kind of Japan chess. So and Alphago and its successor use Monte Carlo tree search algorithm to find its move based on the knowledge previously acquired by machine learning, and especially by an artificial neural network. And here's the concept of Monte Carlo tree search. Just repeat this process multiple times, and it can finish the machine learning. And a short video about the Alphago.
请问你是贪心学院机器学习课程的学员吗？
对，我是贪心学院机器学习高端训练。
Tasks. But what if machines could think like humans? What if software could learn new things by itself? That's been a goal of scientists working on artificial intelligence since the very dawn of the information age, but it's proved a near impossible task. That might be about to change. A piece of software developed in London could just herald the biggest step forward in artificial intelligence and technology for decades.
That software is called Alphago. It was developed playing simple computer games, and now it's about to take on the best player in the world in a Chinese board game called Go. A game of such complexity and intuition, no machine has ever been able to master it. Alphago's creator is the British startup Google DeepMind.
So the game of Go has just 2 rules, but out of those rules comes profound complexity. There are more possible board configurations in the game of Go than there are atoms in the universe. So really it takes a whole lifetime to master. We're ready now for the sort of next step for us, which is the ultimate challenge to take on one of the world's top Go players. So we've decided to challenge Lisa Doll in a $1 million 5-game match. Lisa Doll is the greatest Go player of the last decade, probably one of the greatest Go players of all time. I describe him as the Roger Federer of Go. And you know, the press and the excitement there is just huge from the general population because they really love technology and they love Go. Human professional players at the top of the game, you know, they're extremely creative and they'll do unexpected things that your own systems won't do. So we're pretty confident. Our internal tests are saying we should do pretty well. But Lisa Doll also, you know, he's been interviewed by the Korean press and he's very confident of winning. So it's going to be a very interesting matchup.
Of course, this isn't the first time computers have beaten humans in a board game. But what really marks out Alphago from the machines that mastered noughts and crosses in the 1950s and eventually chess in the 1990s is not just its ability to play a much more difficult game. It's the way it plays the game, by learning.
Alphago actually learns how to play in quite a human-like manner. So the way we start off training Alphago is by showing it 100,000 games that strong amateurs have played that we've downloaded from the internet. And we first initially get Alphago to mimic the human player. So we give it a position and we train it to predict the move that the human expert made. But of course, ultimately, we would like Alphago to be stronger than human amateurs and compete with the top professionals. So the way we do that is, after we take that first version that's learned to mimic human play, we then allow it to play itself 30 million times on our servers, and using reinforcement learning, the system learns to improve itself incrementally through it avoiding its errors and increasing and improving its win rate against older versions of itself. And after all these games, then you end up with a new version that can beat the old version, the original version, around 80–90% of the time.
The computer Deep Blue has tonight triumphed over the world chess champion Garry Kasparov. It's the first time a machine has defeated a reigning world champion in a classical chess match.
Deep Blue, Kasparov, after the move c4, has resigned.
This is in many ways a more interesting piece of software than Deep Blue, which was the piece of code that did beat Garry Kasparov back in 1997. Why are people excited at the moment? I think that's because these machine learning techniques have made a little bit of a breakthrough at the sort of lowest level of functionality that's really important for AI, which is perception. So being able to take raw data, large quantities of raw data, such as images or sounds, and to be able to do the basic processing and recognize what's there.
Key to understanding why Alphago could be a much bigger breakthrough than Deep Blue is to see just how differently the two machines work. Deep Blue was programmed to recognize the value of each piece on the chessboard. It then used raw computing power to search every possibility to work out which one was best. It's a bit like trying every password combination until a safe unlocks. But ask Deep Blue to do anything other than play chess, like even play a much simpler game, and it just won't know where to start. Alphago is different. Like a human, it can't measure all the possibilities in Go. There are just too many. Instead, Alphago teaches itself to play the game by watching thousands of others, playing matches against itself and learning from its own mistakes. When historians come to write about the 21st century, I believe this match will be seen as a pivotal moment in our relationship with technology, because as DeepMind software shows, we may be entering an age of thinking machines and general artificial intelligence capable of carrying out a huge number of tasks currently done by humans. And whether or not DeepMind wins the game, it's likely that intelligent machines are going to have a profound impact on the world around us.
AI can make great contributions to things like medical imaging diagnosis, to self-driving cars, to image recognition processing so that computers can understand what they see. Going beyond this, real general AI means that these systems can do all of these things together and maybe can guide robots to make the right decisions so that they can behave with humans and participate in our world. The whole point about general AI is to not put bounds on any specific thing they can do, but to provide a general resource, a general technology whereby computers can make smart decisions, can understand what they're doing.
That's the really open challenge for AI, is to try to make AI more and more general and more robust to situations that it wasn't programmed for.
The next step for DeepMind's technology is applying it to real-world situations, not just games.
The idea is that these algorithms that we're working on are general purpose and can be translated into these new domains. So we'd love to use these types of algorithms for things like healthcare and science and improve the speed of breakthroughs in those areas by helping human experts achieve more.
The match against the world's best Go player is a key milestone.
So I have a quite discussion here. So what will the competition be like in the future, since the artificial intelligence have already beat humans? So what about the competition in the future? Will it be the competition between AI and AI, or could AI just be the teacher of human and human continue their competition? So that's all.
All right, any comments from the class? No? All right, thank you. So that's team 2 once again. Sorry, what's that?
No.
Yeah, that's team 2. All right, so it's 5 p.m. already. Let's take a quick break. Let's say, let's return in about 10 minutes, okay? So 5:10. All right, see you guys at 5:10.